Okay, my friends, this is going to be another shocker du jour. This is Sabine Hosenfelder, and she's saying, how do we know climate change is caused by humans? Well, how do they know what causes climate change? Let's see what she has to say, and I will make my comments, because I think I can fully understand why we are having such turmoil in the atmosphere, such terrible storms and scrubbings, weather patterns changing, violence, electrical discharges. The electrical discharges and the heat are the key. So let's talk about what she has to say about how do we know what's even going on. And I'm going to tell you right now, I don't think they do. So let's see what she has to say. I'll make my statements, and I'd love to be able to react with some of these people making claims and statements, because I am making claims and statements, but I am showing the evidence to support what I'm saying. All right, so let's talk about it. All right, before we get started, here's what she's going to claim is evidence that climate change is human caused. And these are the 5 different things, and I'm going to address each one of them at a time. Now, before I get started, though, I want to tell you right now, my form of the atomic nucleus is it's made out of dipoles. And the transfer of energy is from light to atomic vapor. Light is nothing more than like mist of atomic vapor, and they're all dipoles, and they come together, and at certain quantities they lock in and they become stable, and those are what we call atoms. All right, so these are zones of stability, but hydrogen is not made out of one big proton and one tiny little electron. No, it's made out of about 1825 or so dipoles, and a dipole just means a black and a white together. It's a bar magnet, basically, and a whole bar magnet globs together and makes hydrogen. But hydrogen, like I say, is 1825 or so. Helium is not 2 protons and 2 neutrons and 2 electrons. Helium is about 7,900 or something. I can't remember. It's over 7,000 particles. So all of these are huge, huge, huge numbers, and that's what allows for all these isotopes and half-lives and nucleophilic substitution. It's the only way you can have it happen. And I had this back in 1970. This was my papers on it. There's only 2 types of things, just dipole interactions. That's all there is. And transfer of energy is from light into atomic vapor. It's just like mist, and it congeals into raindrops. Basically, that's about it. And the bigger the raindrop, the bigger the atom. So let's get started with this, and then at the end I'm going to go over the reason I can make all these claims. This is all my stuff. I did a lot of this work. All right, so let's just start with her statement. She says, we know it's the carbon dioxide that's causing global warming. And we know that the carbon dioxide comes from fossil fuels. I do agree with both of those things, but I disagree with everything else. I'm not kidding you. All right, I'm sure you've heard of greenhouse gases. They say they trap the gas. The carbon dioxide does. And basically that's what she's saying too. She said, we know it's the carbon dioxide that's causing this problem. And we know that the carbon dioxide comes from fossil fuels. Well, both of those things I do agree with. However, I disagree with why. And I can tell you, I will address each one of these, and it will explain it very simply why all of these things are not understood. You have to understand dipole electron flood theory and the ionosphere and how it's just saturated with electrons. There's things they just don't understand. We have to deal with the electromagnetic spectrum and all of these gamma rays and X-rays and ultraviolets up here, where you start getting some serious energy. And then we have to talk about what all of these molecules are made out of, all these atoms. And it's a lot different than what they're thinking. So I'm going to start right off with the beginning of what she has to say. And again, they claim that the carbon dioxide is causing the problems. And I do agree, but it's the expansion of the gases. It's like an envelope blowing up like a balloon. That's the problem. It's not just that it's just holding on to heat. Okay, as I do, I am going to cut in on each statement she makes and address them as she goes along. All right, so here goes. This is Sabine Hosenfelder. She's a very renowned physicist, and she's trying to figure out global warming. So here goes.
How do we know that climate change is caused by humans? I got this question on Twitter and I thought, come on, Google can answer that. Well, the first hit I got on Google is a quote from a NASA website. It is undeniable that human activities have produced the atmospheric gases that have trapped more of the sun's energy in the Earth's.
All right. I don't disagree with that. There's no question whatsoever. It is undeniable human activities reduce the atmospheric gases. The gas is expanding, yes, that have trapped more of the sun's energy. No, that's not the case. It's because we're scrubbing through the universe in an expanded form rather than back here where we used to be. And it's getting scrubbier and scrubbier, and it's causing all kind of turmoil and so forth. That's my take. Now, so she's saying that, or NASA is saying that it's trapping the sun's energy in the Earth system. This extra energy has warmed the atmosphere, ocean, and land, and widespread rapid changes in atmosphere, ocean, biosphere have occurred. Yes, that is absolutely true. And the turmoil and the scrubbing and all that stuff is crazy. And I will explain the layers of atmosphere, and she does too, but she's got the wrong take on it. All right, so I'll let her continue on. Here goes. I'm going to back it up just a swidge here.
That have trapped more of the sun's energy in the Earth system. Alright, but that doesn't really answer the question, does it? Going down the list of search results didn't really help. I then went and asked my pal ChatGPT, which, true to character, produced a lot of words, but didn't really answer the question either. That actually worried me. You'd think people can just look up how we know that we are responsible for climate change on the snap of a finger, but it turns out it's not that simple. To be fair, both Google and ChatGPT did a pretty good job explaining what evidence we have that the climate is indeed changing. Rising temperatures, rising seawater levels, ocean acidification, declining ice covers,
and one of the main things is the turmoil in the atmosphere. Why are we having all these weather patterns changing? And why are these violent thunderstorms and huge amounts of hail and rain and all that stuff? That is compression. That is interaction of molecules creating scrubbing and rubbing and ripping electrons away, creating huge amounts of electrostatic discharge. Lightning. All right, just so you understand where I'm coming from before we go to finish up with Sabine here. I am saying that she is correct that the carbon dioxide is the problem, but it's not that it's not letting the heat get out and it's holding on to all these heat particles. It's because it's expansion. It's an expansion gas. If you take this and you burnt this into like all of its gases and turned it into gases, it would fill this whole room. And this is what we're doing. We're blowing up like this. Now, here we are going through the universe, spinning on our axis, circling the sun. So we're having all this interaction. I'm going to show it to you really, really cool in a second. But here's what happens. This has to spin, and it has molecules attached to it, which is our atmosphere. And on the edge of our atmosphere is the ionosphere. Ionosphere means there's just nothing but ions. Ions are nothing but negative particles. So what happens? We've been spinning through space, and we got our ionosphere somewhere out here, let's say. And it's been scrubbing, and it's been, you get weather patterns and this and that, but no big deal. But all of a sudden, we're burning stuff like crazy, making it like a balloon blowing up. So now, instead of this going through space, this is spinning through space because the gases are what's spinning. The planet's just inside the gas envelope. The gases are what spins. Now let me show you some more, stuff that'll support my claims. And don't forget, there's no question whatsoever, and she's going to show it in a bunch of documentation. The atmosphere is expanding. You burn stuff, it gets a ton more That's what a gas balloon, a hot air balloon does. You burn a couple of little particles, and the thing blows up like a balloon. That's why they call it a gas balloon or a hot air balloon. All right, so we've expanded our layer way out here, so we're scrubbing like crazy. Okay, my friends, this is going to get real interesting because we can see all the particles of light now using this new research tool, which is called the tuned Venturi. Rod Warren discovered it by accident, just by accident. And I saw the pictures he was showing. I said, how did you do this? And he told me what he was doing, and it was a single slit, not a double slit. And it's able to actually create fission and fusion. These are the particles they talk about from Fermilab, and they talk about the quantum foam. That's the other part. That's what we're scrubbing through, is the quantum foam. That's what's causing our gases to heat up at the extreme outer edge of our atmosphere. And when that gets hotter, it gets colder below. I know it sounds crazy, but it's true. The hotter that gets, the colder this gets. It's just the way it works. They're absolutely total opposites. This one has all the weight and no burn. This one has all the burn and there's no weight. Total opposites, and that's why we are having this interaction out at the ionosphere, is with these rubbing each other. Okay, this is a galaxy, and we are in one of these galaxies, and we are on an arm of the galaxy, and it is spinning, all right? And we are spinning, and we are spinning like all kinds of different ways. But our whole solar system is being pulled through the galaxy. And this is what it looks like as it spins through the galaxy. Here's our sun. And it's pulling our particles behind it because we are trying to catch up to the sun. The sun has a huge mass of attractive particles, which are the dark particles, and it's giving off all of the white particles, and they're shooting out as sun rays, and it's got an extremely dark core, and that means it really pulls on everything else. The dark particles are gravity. They are the things that pull everything together. They are gravity, they're dark matter, and here they are right here. They call them Dirac neutrinos. One side's got the black part and one's got the white. And that has all the mass and no burn. And that's got all the burn and no mass. And that's precisely what they say at Fermilab right here. Those are the exact same particles I just showed you of ours. You see them? This one has a fuzzy edge around it, he says, but it's black, and they're always the same size. It's fixed. This one can get big and small, and it has no weight, and it has all the energy. And that's exactly what I just showed you in ours. All right, and here's actually the particles coming down the line as they're turning into photons. You see that? The black and the white together. Side by side, that's a photon. Half of this. In other words, if you just took one black and one white, that's what we always would consider an electron. It's just a single particle. And that's either heat or electricity, one or the other. It's not stable. Once you get into the photon where you have side by side, two of them, well, it's okay. And it creates a field around it. If you only have one of these, you have an attractive field here. All right. The other way, you just have a field around it, and it's repulsive, so it's stable. And before they turn into photons, they are in the neutrino phases like that. And of course, this is red, and it's weak. And these are neutrinos, all that. These are turned into photons because they're just getting ready to explode at the Venturi. And the only time they turn into photons is when they're like hitting a wall. And as far as they're concerned, this is a wall because it's backing up on itself. All right, and that's that. And then the green one's the same particle, and there's no difference. All the particles are the same. Light is all the same particle. Everything is made out of these two little black and white particles. And if you have 1,823 of them, all in one big glob, you have a proton. You add one more, 1824, you have a neutron. It is neutral because it doesn't want one more, or it doesn't want to give one up. Now, I don't know if I mentioned the quantum foam yet, but the same people, Fermilab, they're showing this, their particles. they say it's quantum foam saturates the whole universe, and I agree. And that's what we're plowing through. And quantum foam is nothing more than these particles that are light particles. Because this is light. Where does it go? It comes from the sun. It has to go somewhere. It's in space. It's just dark. You don't see it. But it's a quantum foam. And when other particles bang into these, they blink on and off. Precisely, exactly, precisely what Don Lincoln says at Fermilab. So these are the two particles, the glowy edge around it, the black one, and which is fixed, and then here's the quantum foam. All right, there's a quantum foam. And what he says is empty space isn't empty. It's saturated with these light particles. All right, it says the foam on the head of a root beer is complicated. Bubbles appear, disappear. Dizzying display of change. Now, empty space in space is not empty, so it experiences similar activity. It blinks on and off. Subatomic particles. Subatomic means smaller than atoms. Subatomic. Winking in and out of existence. Exactly the particles I'm showing. These ephemeral subatomic particles are real and have a measurable impact on our universe. And they refuse to engage with about that because it slows light down as it comes to us. There's absolutely no question. As these things are bing, 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 bing coming through, they're slowing down. There's no question about it. See, this is a problem. Einstein caused a whole lot of trouble. He says light can't slow down, light can't speed up, one continuous speed, and every other law was based on that. It's just not true. This is light, fast here, and then slowing down here. Now, that's what's called red shifting. It's shifting from the blue towards the red end of the spectrum. You see this? Blue is way up here, fast. Bzzz, way up here. You get down here, and, well, it's not really, don't forget this. It's way up at this end of the spectrum is blue. All right, that's fast. Red is way down here, slow. So if I was to shift this towards the red, they would call it red shifted. Even though it's blue light, it's red shifted. So they see this, and they see it shifting over this way, and they say, well, the universe is expanding. This is going away. It's pulling all of that light away from us here. It's just not that way. It's slowing down as it comes to us. So that ruins everything, and we have no idea where we are in the universe. None. If we were coming through a place in space that was dense with particles, we're going to impact harder, and it's going to affect our sun. It's going to affect our weather system because of the universe. There's nothing we can do about that. There's absolutely nothing that can be done there. All right, because if you're in a galaxy, you're not going to change that. So if you're coming this way and you're coming into a cloud of other stuff or over here, or you may come into a nothing zone. That's just a roll of the dice, my friends. The rest is expansion of our gases. All right, we're expanding way out like this. It's scrubbing harder and harder and harder. And it's all kinds of tornadoes and hurricanes and overwhelming skies and compression of the atmosphere causing huge ice balls. And the reason is it's getting colder. And they say, well, it's getting colder. That means we're not causing it. No, we are causing it because of the expansion. If it gets hotter out here, it will get colder just below it. And you think I'm wrong? I am not wrong. It's just totally opposite. The hotter it gets here, the colder it will get below. Just the way it works. Total opposites. See, this is the issue right here. This is the ionosphere. Out here, ions mean electrons. And this membrane area right here, in between our atmosphere scrubbing like this, and all of those particles, the quantum foam that's in space, all of those electrons and so forth that we have to scrub through, spin through, we're ripped through, they tear off the particles here and end up with just having nothing but electrons here. And it is just saturated, and it's 1,500 degrees Celsius out there. It's so hot it can destroy meteorites and burn them up and all that stuff. Right there, 1,500 degrees. Guess what? Right there is the zone between the dipole, hot side, and the cold side. It's minus 80 degrees Celsius here. It's an enormous different change in temperature, absolutely enormous. And it is right in that zone between here and here. And because this is getting colder, they think everything's fine. This is getting colder because this is getting hotter. And the colder this gets, the more that really scrub takes off and the bigger the hail becomes because it's condensing here. It's still a lot of pressure now. It's condensing water, but it's turning not into rain, into hail balls. I mean, they're coming down. You see the size of these things. Whoa. They kill the cattle and everything out in the fields. So this is a real problem. And then just below that, it starts to warm back up again. But there's all these layers, and they don't take this into consideration. This is getting hotter because this is getting colder. They say this is getting colder, so everything's fine. We're not causing a problem. Not the case. All right, one last word on the layers. You get extremely hot and getting hotter. You get extremely cold and getting colder. And then this will get hot again down here and hotter. So it's layered hot, cold, hot. That's why the surface is getting hot. And the colder this gets, the hotter it's going to get down here as well. And if you don't think we're spinning through space and the sun is spinning through space, explain this to me, Lucy. This is the moon. It is obstructing the sun. So we're not blinded by the light. We can see what is emanating from the sun's surface. Now, you have to take your time and think. What is that red spot? What is that red spot? What is this red spot? You don't have any over here. You don't have them up here. And what is this shooting straight up out of here and shooting straight down there? I would say these are the poles. And it's spinning, and I would say it's spinning in that direction. And I would say everything is moving in this direction. Therefore, the most impact is here, here, and here. We're having our big sunspots and glowy, brilliant magnetic radiation coming from this impact zone as we twist through all the particles in space. And the sun has become overcome with heat and is shooting out particles everywhere. The surface of the sun is 10,000 degrees. All right? Way out at the corona, way out here where these particles have to get through the rest of the particles in space, millions of degrees. 10,000 down here. They send the particles out. The particles have to scrub. It's millions of degrees. Exact same situation as on Earth. Our atmosphere here is 100 degrees or so. Out here, it's 1,500 degrees Celsius. That's 2,500 degrees, something like that. Way out here. And then it drops down to minus 80 Celsius. There's no other way to understand this. They just have to stop and think about this. But they don't know about dipole flood theory. Dipole electron flood theory it solves everything. It solves 100%. And I've known this for many, many, many years, and I could never prove it until we could do these experiments and actually see the particles and see them separate and see light spinning. Light spins. It doesn't flap like a wave. It just spins like a drill bit. And that's a single slit, and that's why all these repulsion patterns are here. They're not like this. It's a single slit. It's screwing through there, first of all, just like a drill bit. And secondly, when it gets on the other side through the drill bit, they don't want to be next to each other, so they set up these interference patterns, they would call that. And they're not interference patterns, they're repulsion patterns. You stay away from me, I'll stay away from you. I push you towards that guy, he pushes you back towards me. We push, 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 and that's it. You get these patterns. And it's not unknown, it's just not understood. And this is the particles coming through the Venturi. And right here, it's just like off the wall energy. I don't see any reason we can't get free energy out of this. No question whatsoever we should be able to get free energy. Because this is the separation of white from the black. is what do you do when you charge up a carb? You separate, you push only the white in there. The white has no mass. You charge your carb, it weighs 4,000 pounds. You drive all day long, come back, it only weighs 4,000 pounds still. You fill it back up again, still 4,000 pounds. It has no weight. I showed this with atomic bomb blast. How the house just vaporizes, and then when the black particles come, it's all over. It takes off. So this, as far as I'm concerned, I have proven the case that I'm showing. But let's go back to Sabine and see what she has to say about the carbon dioxide. Because my take is it's just the expansion. There's more and more scrub. Okay, so here she is again. Here we go. Sabine, take 2.
Extreme weather events and so on and so forth. But you already knew that. How do we know it's us who are responsible? Let's have a look. This video comes with a quiz that lets you check how much you remember. First, we know what type of light carbon dioxide molecules absorb and emit because we can measure this in the laboratory. Carbon dioxide is really good at absorbing light in the infrared. This is what makes carbon dioxide good at keeping our planet and other planets warm.
All right, this is what I dispute. Carbon dioxide certainly will absorb excess electrons, yes. But it's because of the expansion of the gases that we're absorbing all these extra electrons. They have to go somewhere. Everything will accept them. Carbon dioxide will accept them just as good as anything else. You know, it may be better, yes. I can't say that's not the truth. But everything will take extra electrons, and it just becomes warmer. The more electrons you put into something, the hotter it gets. That's all. So the carbon dioxide may be heating up, yes. I agree with that. But it's not because that's not the reason we're having all these excess electrons come in. It wouldn't heat up if we didn't have the excess electrons. It's because of the scrub.
This is the first piece of evidence. We know what carbon dioxide does. Second piece of evidence is that we can measure how much carbon dioxide is in the atmosphere, and the fraction's been increasing ever since the beginning of the measurements.
All right, that's what I'm saying. Think of it this way. Here's the Earth down here, and all of a sudden the Earth gases are coming up. This is just like that. That's the increase in carbon dioxide.
Together with the first piece of evidence, this gives us a plausible cause of the warming. It's the carbon dioxide. The third piece of evidence is that oceans take up carbon dioxide from the air, and that lowers their pH value, so it makes them more acidic. This is compatible with observations. Other hypothetical causes of global warming, such as an increase in the energy that comes from the sun, wouldn't have this effect. Again, we conclude it's probably the carbon dioxide. Fourth,
the more carbon dioxide you put in the air, obviously it's going to force itself into wherever it can take it, and the ocean will absorb it, absolutely. But it is the increase our carbon dioxide, but it's the pressurization outwards of that, causing like a balloon effect. The exact same thing is happening on the sun, identical. The sun is 10,000 on the surface, millions outward of balloon scrubs. All right, so now they're talking about carbon isotopes. Forget about this. This is total nonsense. They're talking about carbon 12, 13, 14. You know how many carbon isotopes there are? There's zillions of them. And that's because this is not right. This isn't right. How could you have carbon that is all these different carbons? How could you have in carbon 11, 12, 13, 14, 16? I mean, it's unbelievable how many isotopes of carbon there are. Well, all of them, every one, because they have thousands of particles in between each one of these atoms. Look at this. This is just the isotopes of carbon, and then you get into the real specific ones. These are different carbons. These are all isotopes of carbons. Carbon is not just one thing. It's made up of all these little dipoles. All right, I've shown you general relativity. It just isn't correct at all. Speed of light is not consistent. You can go faster, you can go slower. Particles are made of dipoles, and those dipoles make up everything, because they smash these big, huge things to get down to the smallest little particles. We started with the smallest little particles, which is light. And we could see their particles. We're not guessing. They're just guessing at everything. They create what they call a particle zoo and dig through it for 10 years. And they found the same particles we found, but we can see our particles. Now they're going to throw some rules, general rules out. Well, there is no general rules. All right? Laws. What you find out is what you find out. You cannot live with these laws, like Einstein and all the rest of them. All these laws have led people just to walk around in circles. Every theory they have does not even explain gravity. It doesn't explain anything, really. They say gravity describes a tendency of things with mass to come together. Whether it's colliding galaxies, a moon struggling against inertia in its pull towards a planet, or an apple falling to the earth from the top branches of a tree. Models of gravity need to explain why masses attract. Why do they attract together? Yet such a theory also needs to operate in a universe where objects of identical charge can repel each other. Explain why atomic nuclei stick together with incredible force, or why neutrons, let me do this one. All right, just listen to this. They said, nobody can explain this. Explain why atomic nuclei stick together with incredible force. They're little bar magnets, that's why. Case one. Why neutrons spontaneously decay to form protons? Because they have one extra particle here, and sooner or later it gets popped off, and it stabilizes as a proton. All right, so that's that. And they still need to work out why masses become dense. They don't even understand that. Why does some stuff become denser and some become light? I had no idea. All right, so I don't know if I showed you this or not, but I'm going to do it again. Carbon is right here. It's supposed to have 6 protons and 6 electrons. These are all carbons. These are all still carbon. They're all different masses. They're all different half-lives. They're all different charges. They're all different stabilities and so forth. You get up to carbon-12 exactly. That means they're saying it has 6 protons, 6 neutrons, 6 electrons. Well, that might be, but there is no such thing as protons and neutrons. There's just dipole electrons. Now, I can show you how it's very simple to understand. At a certain quantity, at this exact quantity, it's stable. If you take 2 or 3 off, or 10 off, it goes down to here. It's way unstable. It has to gain weight. See this? This is the weight. 8, 9, 10, 11. Now we get up to 12, and then we get 12 exactly, and it's stable. You keep adding more. 13, still pretty stable. But then you get up to 14, 15, 16, 17, 18, 19. This is all added particles. And they just become carbon, but they're in the middle because there's so many of them. There's a bazillion of them. And there's tons of them I have no clue about. And these are half-lives. The half-life, how quick does it change? And how is the decay mode, beta decay and so forth, and what are the isotopes that are formed? And all of this is from carbon. One carbon is supposed to be just carbon. And the same thing with hydrogen. Hydrogen isn't just hydrogen. Hydrogen is 1,825 or so dipoles in a ball like this. And that's why it explodes so much. When you put a little spark in there, it disrupts everything, and they all go at once. Hydrogen, yikes. All right, here's the one where I'm talking about the cooling. She's saying this is good. Let's listen to what she says. This is the 5th piece of evidence is stratospheric cooling. Carbon dioxide warms the Earth's surface. And here goes.
Stratospheric cooling. Carbon dioxide warms the Earth's surface, but high up in the atmosphere it actually has a cooling effect. In a layer that's called the stratosphere, the additional carbon dioxide helps the thin air shed heat more.
No, that's not true. When you get up into the ionosphere, as I showed you before, it's extremely hot, and it's just nothing more than electrons. Below that, it's extremely cold. So my graph was a little better. But she said cools and warms. And up here in the thermosphere, or whatever you want to call it, just before you get out into outer space, you're in the ionosphere. And that's where, I don't even know why it's not even showing up here.
Efficiently. It's known as stratospheric cooling and goes back to a prediction made already in 1967. And the upper stratosphere has in fact cooled, as satellite data show. If the warming of Earth's surface was caused instead by an increase of energy coming from the sun, then the stratosphere would also warm. So we know it's the carbon dioxide, and we know that the carbon dioxide comes from fossil fuels, and really I didn't make that video for you, but so you can send it to your uncle who still thinks it's a hoax.
It's not a hoax. It's real, but it's still not understood. It's the scrub, it's the expansion gases. It's not just carbon they think they can gobble up a whole bunch of carbon and put it in a box and everything will be fine. No. It's expansion gases. We're scrubbing as a huge thing through space. Instead of being this size, we're this size now. And we're just scrubbing harder and harder and harder. And this one was not quite so bad. And I don't know any way of reducing these gases other than to just stop with the fossil fuels, the expansion gases. It's expansion. I don't care how it happens. It's expansion of particles. So if you start with something solid and you burn it primarily, it turns into a gas. Simple as that. Okay, just to establish a taste of credibility here, I took particle physics at the University of Geneva in Switzerland, and I discussed with them my research into the light, and they were, I believe, quite impressed. And you don't have to pay for this. I enrolled for free, particle physics, University of Geneva. 77,000 people enrolled there, and they have instructors. And I talked with them, and they were nice, but they work with protons, smashing them to bits. But I told them exactly what I was doing, using CMOS and using focusing of light, lasers. Now, I also took particle physics here at quantum physics at Professor Shankar. Now, I didn't pay for that either. I'm not a big payer. All you got to do is go on to YouTube, and he's got a ton of courses. And I looked, and I tried to interact, but you can't interact on there. So I have, and he admitted, right? Well, hold on a second. Listen. Check this out. This is Professor Shankar. Nice guy, but he's stuck in, and he realizes that nobody has a clue what they're doing. This is Yale courses, and this is great because there's no commercials, there's no nothing. You can just watch and listen and take in what you can. There's no comments, so there's no interaction, but here goes.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys, because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now, I'm the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So.
Well, he's being cute, and but he's being honest. Nobody can explain quantum mechanics because they don't understand the dipole nature and the nucleus of the atoms. And I'm going to try to explain it to you completely. And this was my papers on this. I'm going to show you, because like my old boss used to say, it ain't bragging if it's true, and it's true. I did a lot of this stuff, and I was as deep as anybody on the face of the planet in this. After I got out of the Army, I was in I worked on Nike Hercules missile sites, and all of this stuff. There's nothing here that is undone. I mean, I did everything: chemistry, thermochemistry, everywhere, the whole 9 yards, to be able to understand anything. You can't understand one little bit in piece and expect you're going to understand everything. No. And what I ended up coming up with is the only thing that matters is that the transfer of energy is from light like a laser, which I'm going to show you we used, to atomic vapor. Light is atomic vapor. Well, what is atomic? Atomic makes atoms. So this is almost like mist that comes together to form atoms. Light is made up of this atomic vapor. All right, and there's only two types of energies. Dipole-dipole interactions. There's polar molecules and nonpolar molecules, and it just depends on where the centers of the positive and negative charges are. That's what dipole interactions are, dipole polarities and dipole moments. And I did all this. I actually calculated out the dipole moment of potassium chloride, I think it was. This goes pretty deep. So, like I said, I ain't bragging if it's true. And this is what I ended up coming up with. It says that protons are made of 1,839 dipoles. Neutrons, just 1,840. And I'm going to show you this solves literally everything there is. And I never could prove it. So I was just told to go get lost because I said light could speed up, light could slow down. Light is made of these particles, and these particles make up atoms, and atoms, and it was go away. So now I have the evidence with the light research that we did, and it backs me up 100%. So I just want you to know that. Have a sterling day.